Thank you for joining us. My name, okay, great. My name is Shiva Natarajan. I am a senior program manager at AWS, and I've helped launch several local zones globally. And I met Brian at the last event. And Randy, off to you.
Yep. Yeah, Randy James, Principal Technical Account Manager. Been with AWS approaching 5 years. Been working with Riot for 4.5 of those 5. Also met Brian at the VCT Valent Championships Tour Tech Talk in Los Angeles. Happy to be here and kind of go deeper on some of the discussions that we had on site in LA.
Awesome. I guess that leaves it to me. So, hey everyone, my name is Matthew Raval. I'm probably one of the few people not based in Boston here, based out of Toronto. And yeah, I'm a solution architect with AWS. Have been here for, again, approaching 5 years. And I primarily focus on the betting and gaming vertical, supporting customers like FanDuel, who most of you have probably heard of. So yeah, happy to be here. Thanks for having me.
All right. So today we'll be sharing some foundational information on what AWS local zones and outposts are, why we need them, how we built them, and how local zones and outposts work. And we'll jump into some very interesting customer use cases. And then I'll hand it off to Randy to talk about how Riot Games has leveraged Outpost and local zones to solve for low latency challenge. And then followed by Manthan, who will deep dive into in betting and gaming space how FanDuel has leveraged local zones and outposts to solve for data residency challenges. And then we'll have some time for Q&A. And if you have any questions, ask Manthan or Randy. All right. All right. Jokes aside, um, let's jump in. So before we jump into the local zones and outposts, I want to kind of start with the cloud continuum. And our customers tell us they want to migrate several growing range of applications onto AWS. They want to deliver best experience for their customers, and they want to provide best tools for their developers. So AWS helps the customers to accomplish these goals by extending the value proposition that we have in our regions and extending that out all the way to metro areas where our local zones and wavelength are present, and further out to on-premises to via our outpost servers and racks, and then even further beyond that to our IoT services and our rugged edge through Snow family of services. And collectively, we call local zones, wavelength zones, and outpost zones as edge computing. Today, our focus will be mainly on local zones and outposts. One of the key features here is that you will notice whether you're leveraging regions, local zones, wavelength, or outpost, it leverages the same infrastructure, services, and APIs for a consistent customer experience. Just to level set, most of you may be familiar with regions, and I'm going to give a little bit more foundational information and then jump more deeper into these. Regions are basically collection of availability zones which are geographically dispersed across the world, and we have 32 regions far and growing. And availability zones are again a collection of multiple data centers, and the availability zones are set up such that they are also geographically separated so that any incident like flood or fire or tornado that's happening or impacting one local zone or one region on availability zone doesn't impact the other availability zone. Okay, so we'll jump into why we built our local zones and outposts. some might ask, okay, you have 32 regions. Why do we need these local zones and availability zones? Let's think of a customer in Houston trying to connect to regions, right? By the way, Brian, or can you all see my screen?
Yep, we can.
Okay, thank you. So let's say we have a customer base in Houston area, and the nearest region is a Northern Virginia region. And to for their request, the traffic that has to traverse multiple ISPs or different network paths to get to the Northern Virginia region. And this usually is in the order of tens of milliseconds. While it works for the majority of use cases, there are specific use cases that requires ultra low latency and workloads that require, like real-time gaming, where latency is a big factor. This particular latency to get to the region doesn't work, and then they have other operations that happen within the region to process and send back the response. And to solve for this, primary drivers for us is latency and also data residency, which is why we built these local zones in first place. The pink dots here kind of represent local zones broadly. So now if you have customer able to connect to the local zone, they don't have to traverse the network path they had to get to the region. Their local Houston facility or local zone can run their jobs locally and provide faster latency, faster response to the customers. So it's like another flip view of this from a customer gaming experience perspective. Like you have customers of, say, for example, Riot Games, like they're distributed across geographically different states. And let's say they're connecting to a server in the US West 2 region. As you can notice, some customers get a 15 millisecond latency, and some customers who are either farther out potentially can get 60 millisecond latency. And in certain games like Valorant, which is, as Brian mentioned earlier in the call, like it's very fast paced, and this particular different it could be a very differentiating factor and could be a leading to advantage for one player versus the other. And overall, from a service perspective, we want to provide outposts or local zones in large metropolitan areas or where it's required so that we can smoothen out and have this round trip latency much more distributed. And Randy will talk about this in his deep dive in a lot more detail and explain from the context of the Riot Games. Okay, so now we talked about in a high level what local zones and outposts are and why we built them. And we're going to talk about how we built them in this particular. So all the hardware and the design and the thought process and the learnings we got from regions for, we have been in regions for 10 to 15 years. And with all the experience, it led us to build outpost and local zones with the same type of racks and hardware that we built in our regions, which is again built on our Nitro system, which is basically providing higher security and encryption such that all the communications happening across the regions or happening within VPCs or it's highly secure. And AWS monitors these fully and 24/7. And it provides same single pane of management. For example, if you open the Apple EC2 console, you could have multiple EC2s running in that same region, and it all looks alike. It's no big differentiator between those. And so let's jump into some common customer challenges. And as we discuss latency, and this is one of the most popular drivers for our customers. And real-time gaming were to 2 milliseconds to 35 milliseconds have been established as like a benchmark for optimal customer experience from a gaming perspective. So to solve for those and support those real-time gaming experience, our regions are not everywhere, and to supplement those, and by providing local zones and outposts where it's available, helps the gaming servers to run locally close to our customer base, thus providing the ultra low latency. Another use case is about local data processing, where think of a big factory floor, or think of a automated car, or think of a lot of IoT sensors where a lot of data is being generated locally, and some decisions need to be made immediately based on analyzing that data. It's not feasible because of latency or financial constraints to move this data out, get the processing done, and bring back the analysis and make a decision. So in those situations, outposts or local zones bring the ability to act on that data much closer to where that data is generated. And data residency, like FanDuel and Tipico or several customers, it's one of the more popular use cases now that a lot of folks are interested in data residency, mainly driven by regulatory requirements. And think of like governments trying to keep the PII data within a country's boundary, or in case of FanDuel and Tipico, or betting and gaming industry, they have gambling industry, we have to have data within a particular state boundary, or in some cases due to contractual negotiations, it also requires to run in a particular data center. So to solve for all these, since regions are not everywhere, local zones and outposts really helped in solving this challenge. And last but not least is the modernization and migration. Some applications are a lot more conducive to run on cloud. And or even if you have some applications you want to migrate to cloud, that's a much more conducive. But there are certain applications, like very monolithic architecture-based applications or mainframes or ERP applications, are not very conducive to move to cloud. So to help those customers migrate this, they either have to refactor or replatform or re-architect basically to eventually migrate to cloud. Outpost and local zones provide like a stepping stone for these type of applications to migrate to cloud. Eventually, when a lot of interest is in a lot of companies are investing in modernization, leveraging container-based microservices architecture, and AWS has made significant investment in the container orchestration service, EKS, and also ECS. So both ECS and EKS are available in local zones as well as outposts. All right, let's kind of jump into Outpost. So Outpost is a fully managed service that extends AWS infrastructure, services, APIs, and tools to any customer on-prem location or a co-location space. So we say fully managed because it's fully assembled, and Outpost comes in two form factors. One is the industry standard 42U rack, which kind of looks like this, and it comes fully assembled, cabled, and everything is ready except for rolling into it in data center. It's installed by AWS, and it has centralized redundant power conversion units. We've learned from our experience and the commodity based data centers that power is one of the big failure points, and we built these systems such that it's redundant and power disruptions don't impact any customer workloads. For Outpost servers, for applications where for if you have a data center space constraint, or if you have a deployment such that you have to deploy several of these in different retail locations, it also comes in smaller form factor with one new Graviton processor, which provides a high price performance ratio, and also in 2U form factor, which run on Intel processors. All right, so what does the inside of an Outpost look like? So inside of the Outpost, you have several hosts that you could plug in. This is one like I was mentioning earlier that it comes all pre-assembled from. The hosts are basically, or the different types of servers you could plug into these, and this is highly configurable. And for example, if you have a very compute-heavy workload, you could choose from the C5 family. And today, Outpost and LocalZones really mainly support 5 series or 5th generation like C5, M5, R5, and G4DN, and some EBS. And you could make any combination of these that is more suited to your particular workload. And you can have multiple racks within your own data center. And we also have spaces, this, there were several instances where we built out Outpost rack, and then we had to infill hosts. And we typically save that bottom space to help for that infills and to add additional capacity to an existing Outpost rack. We have network switches in the middle, and it connects to the patch panel that really provides an uplink and connectivity to your data center. And these could be through lags, or connect multiple of them could be combined together to provide higher bandwidth connectivity. And the power supply is a redundant power supply. We have AC power and also DC power within those racks. And if one power supply had some issues, we had this is a bus bar that kind of distributes power across the entire rack. And if there are issues, it kind of flips to the DC and run on the DC power. All this to say, this is highly redundant, and it helps your workloads to run consistently. And if you run your workload in region or within Outpost or local zone, you can expect the same performance, and you can expect the same type of hardware and where and all the same experience from a customer perspective. All right. So from an architecture perspective,
we do have a question. Can you deploy an Outpost rack to a customer-owned rack? And yep, Nathan is answering the 1U and 2U servers can be put in your own rack.
okay. Yeah, the 42U racks is basically all assembled, but like Manthan said, 1U and 2U could be. All right, good to go. All right, let's quickly jump into how the Outpost racks work. So through the EC2 console, once you have ordered an Outpost rack, it's often individual customer-based order, and you have to have some sense of your workload to order that. And once you have ordered those racks, and it's plugged in, powered up, and ready to go, all network ready, you via the EC2 console, you create an outpost. And once you create an outpost from the closest parent region, you extend the VC all the way to this outpost by selecting the outpost ARN. And once you have put that extended your VC to that outpost, it just looks like in and behaves like any other available zone. And you're automatically you get the rules and rules and security groups associated with this, and it provides the ability for you to communicate with other E2 instances in the region if you have to. And for the most
Shiva, if I
part,
can just interrupt
the
for a
power
second.
of Outpost customers.
Shiva, you're breaking up just a little bit. I wonder if maybe you turn off your video. The audio might be better.
Or turn off the video. Okay.
Yeah. Okay, go ahead.
All right. So I was saying once you have extended your VPC, your outpost just looks like any other availability zone. Can you hear me okay now, or is it still having some disturbance?
I think it's a little better.
All right, great. Let me see. All right, so we also have a logical construct called local gateway. And through local gateway, the traffic within your outpost, you can launch EC2 instances within your outpost. And the local gateway enables communication from your local EC2 instances all the way to your on-prem servers. And there is also like customer-owned address spacing that's available within the outpost to connect to those workloads. And the another construct I want to share with you is the service link. So since outposts are parented to a region, our control plane for outposts are in the regions. And this helps to get the telemetry and monitoring of all the EC2 instances running on your outpost. So a lot of our customers benefit from leveraging the local gateway and connecting and running their workload on premises or running their workloads in a combination of mainly a combination of your EC2 instances running on your outpost and some on premises. So one other construct I want to share on this is what is considered within our border and outside our border. Outposts are generally considered outside of our border, which means any egress traffic will be, charged. So if you have a workload that is contained within your VPC or contained within your outpost, then you don't get any egress charges, and the communications to your on-prem workloads it also doesn't get any charges. On the other hand, local zones are considered within our border. So there are that's a distinction I want to basically call out here. And another construct I want to share is since it's parented to a region, if you have other regional services like CloudWatch, CloudTrail, and other services could be easily leveraged alongside of what services are available in local zone or outpost. Okay, let's quickly jump into AWS local zones. Local zones are a type of infrastructure deployment that places compute storage and select services closer to large metropolitan areas or IT centers, enabling single millisecond latency to end users. Just like Outposts, for local zones, you have to kind of opt in or enable that local zone through the console. And just like we did for Outposts, you have to extend the VPC. And once you extend your VPC, you can start creating your subnets and running your EC2 instances on it locally. From end user traffic can can reach the EC2 instances via the internet gateway, both ingress egress. And if you have some hybrid situations from your on-premises, you can use IPsec tunnels or direct connect service to reach the EC2 instances. And you can also leverage Direct Connect. All the other VPC level constructs are similarly available for these as well. The Direct Connect combination along with Outpost is a very powerful solution for latency sensitive use cases for several of our customers. Another way to look at it to understand local zones and Outpost is through the construct of what services are available. And our customers have shared with us that foundational services like EC2, EBS, ECS, EKS, Direct Connect, and VPC are foundational services that are available across all the local zones. And there are certain local zones, like our LA local zones, where certain other services like Elasticache are made available for specific customers. So in essence, basically, we are enabling running these services closer to end users and running those workloads closer to where the customers' end users are. All right. I think we touched on this a little bit earlier. Similar to Outposts, local zones are also parented to a region, and you can leverage like other services such as CloudTrail and auto scaling, which is one of my favorite services. And you can leverage even data from S3 bucket, even though it runs regionally, but you can leverage data from those for if your application workload needs to. Right. Outpost has a little bit broader set of services compared to the local zones. Like you have S3 and EMR and RDS services available on Outpost on top of what we saw earlier for local zones and few other services like ALB. But pretty much, it's not the 200 plus services you have on a region, but it's a much broader set of services that really helps our customers to migrate their workloads and help with their specific needs. And this set of services is also growing as all right. Let's kind of jump into our customer use case. So for content creation artists at Netflix require very low latency in the order of 5 milliseconds from their workstation to these servers. So for that reason, they had to be on-prem prior to having local zones. With the local zones and direct connect combination, we are able to achieve 1.2, 1 or 2 millisecond latency for these content creators to work on workloads such as video editing or content creation, like the posters and such they create. So Netflix was able to provide their artists with a smoother experience, and they were able to work remotely because of their proximity to the local zones. So another customer from a bookmaking business or betting business wanted to expand in the US at Pico, and they were already leveraging cloud services. And when they wanted to expand in particular locations in US, they had to comply with the state regulations for data residency regulations, as well as at that time when they were expanding, they did not have outposts and local zones in multiple locations. So they couldn't rely on commodity hardware for their purposes. Then, so with outposts, when outposts were available, they were able to rapidly expand and enter US market by leveraging a cloud-centric operational model, and also they were able to leverage their existing infra code. So this enabled Typico to basically faster speed to time to market while meeting their regulatory compliance requirements. And one last example I want to share with you is around how NASDAQ, which is one of our financial customers, have migrated their MRX option trading exchange, part of that to our part of that to Outpost as well. So prior to Outpost migration, the connectivity from their data center to the closest region was taking like an average of 20 plus milliseconds. And when they migrated over to local zones, that dropped from 20 milliseconds to 5 milliseconds. And then further, when they installed Outpost racks within their location, it dropped to sub-millisecond, less than 1 millisecond. So to summarize, Outpost and local zones help to helps customers to expand their businesses and meet the compliance requirements where regions alone cannot provide that. And with that, I'm going to hand it over to Randy. Thank you, Brian. Any questions?
There's been some back and forth in the chat, but I think those questions got answered in the chat. So I'd say, yeah, carry on.
All right, Shiva, you want to pass me the screen?
Yeah, I should be able to share now.
Yep. Are you seeing my slideshow?
Yes.
Great. Okay, thanks Shiva for the introduction. So I'm going to talk a little bit about Riot's use case, Riot Games' use case in particular with low latency gaming and why they chose Outposts and local zones to solve challenges. So first, a little bit of background on Riot. League of Legends was Riot's first game, and starting in 2009 and for 10 years, Riot's only game. In 2019, League launched a new game mode called Teamfight Tactics, or TFT, which was an auto battler, so a different style of game, but using the same game server engine. And during this launch was the first time that we started bringing League servers to the cloud in AWS. During that, they had an event, League 10-year anniversary, or the L10 event. Riot started to use this event to burst beyond what they could run in their data centers into the cloud to serve their growing player base for all of their games. At this event in 2019, Riot launched their plans to put the S in Riot Games by announcing a bunch of new games that they'd need to launch, and also titles that are in development. And it was critical that we were able to work with infrastructure to be able to keep up with their ambitious plans for launching multiple games. So as this was right about the time that I joined the Riot team as their TAM, and I've been working with them since to deliver these game launches. I was part of the launch for all of the games that, with the exception of League of Legends, and been working to help them with data center migrations, most recently into the local zones. So kind of high level overview of how a game architecture works, or how Riot builds their games. We have a game client that connects to a platform service. These are your things that aren't the game server that support it. So think your standard login queue, auth and matchmaking processes, lobby, store, post-game analytics. So those are all platform traffics, and that platform traffic is not really latency sensitive. It's you can it's TCP traffic. It's retries and sends, and it's outside of the core game loop. The actual game simulation itself is very latency sensitive. It uses UDP traffic to send messages from players to the game server process, and that deterministic process collects those actions coming in from players and reflects them back after running the game, and updates the state of the world for all the players that are involved. So latency is really important. for game servers. And in the early days of League of Legends, game traffic was routed like regular internet traffic is today. ISPs, they're the ones that control your destiny with regards to which path to the server you'll take. They may have congestion. They send your traffic whichever way is best suited for how they operate their network. Sometimes it's based on congestion, sometimes it's based on cost, but it's typically kind of a hot potato routing scenario where the goal is to move your packet along the network and get it off of their network as soon as possible, and that leads to suboptimal game performance. In this example on the map, the ideal path from a player in San Jose, California, would be to take the 14 millisecond path to Portland, but their ISP instead routes their traffic to LA, Denver, Seattle, and Hillsboro, resulting in a 70 millisecond path of latency, which is bad for gameplay and very inconsistent as a player experience. So Riot wanted to fix this. They wanted their games, they're very focused on player experience. So they set out to build their own ISP for League of Legends called Riot Direct. So they built this ISP by selecting peering providers that had low latency, fast path networks and connectivity in the networks where their players were at, large cities, typically wherever your cable modems and every other large metro. In order to control the traffic flow, they manage BGP communities, and they use a cold potato routing approach where the goal is to get traffic on their backbone as quickly as possible and route it to the game server and back along that same path to eliminate these extra hops and provide consistent player experience in the process. So the network uses Anycast IPs to find the nearest pop, similar to how a lot of your popular DNS systems would work, where everything appears like it's 2 milliseconds when you're doing DNS lookups, regardless of what house you're or where you're running it from. And this is a very scalable way for them to build their network. And as they improve their peers and paths, all the players benefit. The other thing that they realize, now that we have sort of consistent throughput and traffic, the game server location and placement becomes critical. That diagram that Shiva showed earlier, where we had a server that was in Oregon, is great if you're in Oregon, but if you're in Chicago playing against someone in Oregon, there's going to be an unfair advantage to the player that has the better network. So having Riot Direct in place enabled Riot to think in terms of where should the game servers be. If we have a player population in North America, how do we get players on the East Coast and West Coast playing within game requirements and at equal performance levels? So this is why they selected Chicago for as the primary home for North American game servers. So fast forward to well, not really fast forward, it's a year later, but a lot of stuff happened in the launch of Valorant versus League. We've got a brand new game, and this is a cloud first title, containerized platform that it runs on, using a bunch of new services, but a cloud first approach. So ideally, we would use a region. If the region wasn't available, we would use an outpost running inside of one of Riot's facilities. And if we didn't have an outpost, if we couldn't sell an outpost to Riot for use in that particular data center, then Riot would run on their own metal as they had in the past. So we combined the region Outpost and Riot data center approach with AWS's edge locations, Global Accelerator, and Riot Direct to launch this game. So the cloud first launch, it came with some new challenges for Riot. The first one was this is a brand new game. League had proven itself successful. Riot had high hopes, and initial feedback on the game was positive, but we didn't know if that player interest would remain. So we needed to be able to scale it down if needed, if things didn't go as expected. The fair gameplay, it was very dependent on network and server performance. So we had to get that right in order for the game to be successful. So, and again, this is a large scale global launch using relatively new AWS services. Outposts were announced the year before, and Global Accelerator around the same time frame, and both of these were new services for Riot to incorporate. So it was a big kind of a trusting moment, and we earned that trust through this launch with the services. And the other big challenge was if something went wrong with this launch, we had the potential to impact League of Legends or teamfight tactics in the process. So talking a little bit about Valorant's design goals and sort of why we care about performant game servers and networking. So to be successful, we needed to make sure that the games were fair. Players are going to spend a lot of time mastering Valorant, and that should pay off. So we need a way to prevent cheaters from ruining games and minimize unfair advantages for players that have better hardware or networks. We need to support a wide range of setups. Players should be able to compete in Valorant, even when networks or computers are under-spec'd. So, the challenge here is to provide the best possible experience to each player, given whatever their network and hardware setup would be. And just as important, an individual's network or machine performance problems should not impact the other 9 players that are in their game. So if we have someone who has an extreme network condition, that shouldn't ruin the game for other players in the process. When you're playing Valorant, it should feel like every other player is right there next to you playing on a high-end gaming machine. Another goal for the gameplay itself is for movement to be smooth and highly responsive. Smooth, predictable movement is essential for players to be able to find and track enemies in combat. The server is the authority for the state of the game, but inputs to the server can't just be blindly sent. The client's always locally predicting the results of your inputs and showing you the likely outcome on screen. So the challenge here is predicting your movement on the client allows crisp, low latency response for your local inputs, but this can cause a problem if the server and your local client disagree on where you're at in the game map. So if the server disagrees with the client's view, it sends a correction to the client that causes the client to get back into sync. And the player experiences this as a camera, sudden jump, or characters move around erratically, a rubber band on their screen. And this makes them obviously hard to track and fire shots at. So the design goal of the game was to prevent these types of disagreements entirely for reasonable networking conditions, and then minimize the impact of them when they're unavoidable due to the network loss or latency bursts that are just kind of inherent to running network connections. So the other key design goal was that the gunplay should feel rewarding. Like building a weapon system that's intuitive and deep was the first step. The simulation and the networking layer need to ensure that the results of each gunfight are easy to understand, and provide clear visual feedback. And the fight needs to feel fair to all the participants, and the server needs to respect all of those clutch shots that you land and make it clear where your missed shots actually landed when you don't hit them. This one's a little more meta game. I don't know if you play tactical shooters, but a core tenet in the shooter genre is the idea that a player holding territory should, on average, have a slight advantage over a player taking territory. So this is called the holder's advantage. It's and it's a critical incentive to some of the key gameplay elements of a tactical shooter. The challenge here is it takes time for an attacker that's peeking around a corner to send that info to the server and have that reach the defending player. By default, this gives the attacker more time to see their opponent and line up a shot. The challenge is faced by any online competitive shooter, and it's commonly referred to as peeker's advantage. So peeker's advantage is in direct conflict with the game design goal of holder's advantage. And this was the challenge that we really set out to understand and help Riot solve. So here's a little demonstration of peeker's advantage in effect. If you look at the clip, you'll see that there are a few frames where the player on the left has rounded the corner and can see their opponent, and the opponent doesn't see them on screen yet, so they don't know that they exist. So this network desync is generally bad for gameplay and counters Valorant's design goals. So this is kind of breaking it down a little bit differently. Valorant, it has a very low time to kill. Most weapons can kill with a single well-placed shot. And when a player peeks out from a corner and comes face to face with an enemy, every millisecond counts. So behind the scenes, when the peeker rounds the corner, the peeker's game client sends that to the game server. The game server sends that to the holder's machine, and then the holder can see that. So that whole loop has to complete in a way that's fair. Here's a deeper peek into kind of how the logic of that all works. Essentially, peeking player can see the holding player as soon as their computer processes the input and predictively moves them around the corner. The holder won't see the peeker's movement until the movement input goes from the peeker's client to the game server. The game server processes that and then transmits it to the holder's machine. And then the holder's machine's client applies that movement and draws it in the new position. This approach, in the way that Riot kind of broke it down and figured out what their latency threshold would be, is a really interesting read. There's the same as the title of this slide, a technical blog at Riot called "Peeking into Valorant's Netcode," where they go into the details of how they got to the latency target that we use to figure out what type of infrastructure to run. So TLDR, that math added up to a 35 millisecond round trip time latency target for at least 70% of the players. And the game servers needed to run at 128 ticks per second. So this is the number of updates per second that the game server is doing calculations and transmitting them back to players. AWS enabled this low latency gameplay with servers around the world in all of the locations where Riot needed them. And we used Riot Direct, the network that was built for League, along with Global Accelerator, to provide a consistent backbone performance to deliver the UDP traffic to the nearest game pod. Regions were favored for the launch, large capacity, global launch, and generally covered most of the world. But in the places where we didn't have regions available to meet the 35 millisecond thresholds, we landed AWS Outposts. So today, Riot's running their game servers in local zones and new regions, which have replaced the outposts that we originally launched Valorant with in 2020. We've launched a few new outposts to serve Riot's games in Bogota, Colombia, Bangkok, Thailand, and Ho Chi Minh City, Vietnam. And throughout 2022 and 2023, AWS has been working with Riot to decommission their data centers in favor of local zones to bring League of Legends some of the same benefits that enabled us to move so quickly and so successfully with Valorant for launch. So it's been a great journey with Riot Games. I'm extremely blessed to have been a part of it. And still be a part of it. We've come a long way since League launched in 2009, and there's a lot more ahead. AWS partners with Riot to solve the next set of challenges as Riot launches new games and completes their journey to exit the data center. The player experience drives Riot's game designs, and AWS works backward from customer experience and feedback. So it's a really good fit as a customer, and we take their use case and their design goals to heart with the work that we've been doing. In Riot's case, trusting AWS to deliver a major global launch using new services like Outposts in Dallas, Atlanta, Warsaw, and Madrid was a strong signal to us that customers needed something localized, and was a major voice in the development of local zones and the selection of locations that they would be needed. And it's been good recently working with Shiva and team to continue that with all the migrations that we've been doing out of the data center. So that's thank you guys for giving me the time to present this. If there's any questions, I wasn't reading the chat as this was happening. So are there any
All good in the
questions from the
chat.
top? All good in the chat? Okay, cool. Then with that, I will hand it over to Manthan.
Awesome. Let me take over. Cool. If you can let me know when you can see my screen.
Yep.
Great. Yeah, thank you, Randy. Yeah, I mean, in Randy's use case, he covered how edge services like Outposts and local zones really enable his customers to create low latency experiences, which are really necessary to minimize peak disadvantage and some of the concepts that he talked about. For this section, we're going to focus on a different kind of gaming customer, and that's really sportsbook operators, which is the area that I deal with. So as a customer operating in the betting and gaming space, although having good latency is of course important, because ultimately having too high of a latency will impact your end users' experience. It's really the regulatory nature of the industry that drives the requirements for edge services like local zones and outposts. So what really falls into this betting and gaming space, at least in the United States? On the slide, I have 6 categories. And the important thing to note here is that depending on the type of game, the applicable regulations that must be followed can vary significantly. Take, for example, skills-based gaming, right? Where an outcome is really determined based on a player's ability rather than chance. In this form of betting and gaming workload, there's really minimal regulations on how you can deploy and run the services. Whereas if you look at sports betting, which is going to be the focus of this presentation due to the customer, FanDuel, that I deal with, this is a highly regulated workload, which must abide by data residency and licensing and other terms. Now, one thing that I just wanted to add to this slide is if you have any legal questions, if you're in betting and gaming vertical, I would recommend, speak to your legal department around guidance on what the requirements are, right? AWS does not provide those. So yeah, we defer that typically to the customer. But yeah, I mean, these regulations are what position the edge services as good offerings for customers. So yeah, we'll just take a second to go into, what are the layers of regulations in the US, especially when we look at sports betting, right? And as you can see from the slide, there's really three layers, and these layers influence the how and where, specifically when we talk about sports betting workloads. So when we look at like the federal layer, for example, The key regulation there is the Federal Wire Act, which I believe was passed in 1961. So like everything else in the industry, the reason for the Federal Wire Act is pretty interesting in itself. It was actually put in place to curb the stranglehold that the mafia had at the time. So before the Federal Wire Act came into play, mafia could rig games and then place bets over the wire or the telephone at that time, to on the outcome of a rigged game across state lines. And as a result, the mafia was really impacting legitimate businesses across the U.S. And then secondly, the mafia could also set up their own operations that accept bets for rigged games. And they'll be able to accept bets from across the country, impacting a broader range of citizens. So when the Federal Wire Act came into play, it dictated that wire communications could not be used for bet placements across state boundaries. And today, the primary wire communication infrastructure that most of us leverage and what we're using right now to have this call is the internet. So the Wire Act still is in place, and really the way that it manifests itself today is the fact that if you have a workload that's in line or assisting with the placement of a bet, it must be in the same state as the end user. So you cannot run your architecture in in California and have users from Massachusetts, for example, place a bet into that architecture. For bet placement, the infrastructure must be in the same state as the end user. So beyond the federal level in the Wire Act, we're also bound by state-specific regulations. So this is another layer that needs to be considered. So in the US, each state has its own governing body, and this governing body really dictates what betting and gaming workloads can be operated. So remember, we had the 6 categories earlier. It's at the state level where each state decides, is sports betting allowed? And then they can also decide where and how sports betting is can be is allowed in the state, right? So the how is, hey, we're going to allow sports betting, but it's only going to be in physical facilities. Or a state might say, we're going to allow sports betting, but it can only be from licensed operators that are operating in licensed facilities. And the mode that which end users can communicate can be online and in person, right? So the Federal Wire Act dictates, it's the first regulation that dictates where infrastructure must be in terms of state boundaries, and then states have their own power to then control within their jurisdiction how and where and what is allowed. We're gonna skip over the tribal commissions for our purpose of our discussions today. And yeah, that's pretty much what I want to cover in this slide. So with that said, that brings us to the map of the states in the US that currently allow online sports betting. This map continuously changes, which is why I have this this disclaimer at the bottom. But seeing this map, those familiar with AWS, you'll quickly come to the realization, hey, we have 4 regions, and those regions are not in a lot of these states that allow online sports betting. So how do operators like FanDuel run their workloads across the 22, 23 states that have legal online sports betting, right? And of course, from the topic at hand and what you've been hearing today, the answer should be clear: LocalZones and Outposts. This is the gap that these services fill. So yeah, this is where edge services come into play. Now, for this slide, I've placed infrastructure offerings on AWS in a hierarchy from left to right. And really, this hierarchy should reflect the order of preference that you should have when choosing one of these infrastructure offerings, right? So on the left-hand side, we have our regions. And really, you should be using region unless there's a latency requirement, like Riot's use case, or you have a workload residency requirement, like my customers in betting and gaming. The region offers the most when it comes to scale, the breadth and depth of services that are available, as well as things like high availability, right? There was a question earlier on in the chat around, hey, how do I architect for high availability? Well, if you're using the region, it's as simple as deploying in availability zones and then using DNS or load balancing to distribute traffic across these availability zones. In the local zones and outposts, that's not the case, right? In most states, besides Los Angeles, we only have a single local zone facility. So when we talk about high availability, you're going to have to think about either failing back to the region, or you'll have to think about maybe using a combination of local zones and outposts or something akin. And then similarly on an outpost, right? An outpost is deployed in your data center. So again, now the responsibility is on you to determine how you're going to achieve that high availability. Are you going to deploy 2 different sites that have a 42U rack or a 1 or 2U rack? Or are you just going to use the outpost to meet your low latency requirements? And then if that site, knock on wood, it doesn't go down, but if it ever does go down, you would fail back to the region, right? So yeah, regions should be your first choice from capacity, from service availability, as well as from a high availability perspective. But what if regions are not available, right? And you need to meet this the workload residency requirement, or you need to meet this low latency requirement. Well, then your next option should be local zones. And in the case of betting and gaming, there are 2 conditions here. It must be available in the state, and it must be permitted to use. So the facility must be licensed for use, right? So as Shiva mentioned, right, local zone is second after regions, because this is still a managed offering where AWS controls the network connectivity, power, capacity, and other aspects. So you can deploy instances in an on-demand fashion, similar to how you do in a region. And in US, we have 17 local zones currently, but this number continues to grow based on signals we receive from customers like Riot and my customer, FanDuel. And then lastly, we have Outposts, right? So this is what you should be looking at for either high availability, or if a local zone or a region is not available or not permitted for use. The Outpost is deployed in your own data center, which means that now you need to make sure that the data center has the appropriate licensing, and you will also need to make sure that power, networking, redundancy at both of those levels are present. And lastly, also, you now need to have more of a role in capacity planning, right? Because now you are deploying a restricted amount of capacity into your data centers, and as with anything hardware, it's not like you can go into the console and say, hey, I want an additional 48 vCPUs of capacity. It's going to take time to deploy the additional capacity. So yeah, there's that onus on you with Outposts as well. Yeah, that's the hierarchy. I'll pause here for a second and see if anyone had any questions, or we can move on. Oh, so let's move on to the common architectural patterns that we see for betting and gaming workloads, right? So here, the key thing is, again, we want to make use of the region for things that we can use a region for. So the way that most customers, including the one that I support, look at this is, what are the aspects of our workload that are regulated? And again, this would be something they would decide with their legal team, right? AWS cannot tell you what is regulated and what is not. But yeah, they first decide what are the aspects that are regulated, and these regulated components, in this case, for example, the player ledger and the settlement engine, would reside in a local zone or outpost where they can operate in a compliant manner. On the other hand, for things that do not have regulatory restriction, for example, analytics or marketing, there's no reason to deploy those at the edge, right? So again, we urge customers to deploy those workloads in the region where you have all the advantages we talked about earlier. For example, like if we deploy our analytics specifically in the region, you have 2 advantages right off the bat that I can think of right now. One is you can build a data lake on S3. You're not restricted by storage and those kind of things that you would be at the edge. And then secondly, you also have access to tools like Athena to query the data that's in the lake, right, or process it. Again, those services, as shown in Shiva's slide, are not currently available at the edge. So these are things to think about when you're deciding, hey, do I want to deploy something at the edge? Is there a requirement for it, or can I get can I use the region? And so far, our focus has really been around meeting these regulatory requirements using the edge services. But if we take a step back and look at the offerings like Outposts, the question that many of you might have might be something along the lines of, as an operator, why would I choose to deploy an Outpost versus something self-managed like myself, like an OpenStack cluster, right? And that's kind of why I put this slide in place. And really, there's two reasons why customers like FanDuel, for example, prefer the Outpost approach. If we look at the hardware perspective, the first item here is what happens if there's an on-prem server and it has an issue. Well, if you're managing and deploying your own OpenStack or etc., offering a virtualization offering service, you are ultimately responsible for maintaining your equipment as well as monitoring it. So if a failed component, if a failure happens on a component like a hard drive, you need to be monitoring it, and your team needs to then order the replacement parts and replace that. With an Outpost, it's a managed service. So even if we ship the 42U rack to you, 42U rack, the power and networking, they're the responsibility of you or the data center operator, but the individual like networking components, compute components, and storage that make up that rack, those are all being actively monitored by AWS. And if any failure occurs, a TAM like Randy or somebody else would reach out to you and organize a schedule for replacing of that failed component, right? So that responsibility, again, of maintaining and monitoring the equipment, it's offloaded from your end. And then secondly, on the hardware side of things is the time it actually takes to acquire the hardware itself. So for sportsbook operators, this is really important because being the first to go live in a particular state, when the state goes live, usually results in capturing a large percentage of the market. So when a state gets ready to legalize online sports betting, all systems must be ready to go live. Looking back at when FanDuel, for example, started their journey with Outposts, there was a little pandemic that you may have heard about that really had a bad impact on supply chains. And so, just from hearsay from other customers, there were certain vendors, OEM vendors are producing servers who were backfilled by 6, 7, 8 months, right? And that uncertainty for FanDuel was just not acceptable. They needed the hardware to be there, racked and ready to go when a state went live. So they found that through the Outposts, since AWS really manages that relationship with component manufacturers, a side advantage for them was that there was more consistency to when parts were delivered. And so they were able to acquire hardware and operationalize their stack with more consistency and in weeks versus the months lead time that they would need to plan for otherwise. And then we have advantages from a workflow perspective, right? As Shiva mentioned, the advantage here is that the same core of services and APIs are available in a local zone or outpost as what is available in the region. And so when we look at things like EC2, Elastic Cloud Compute, what we call our virtual machines, right? You can deploy these EC2 instances in an outpost subnet exactly the same way that you would deploy in the region and exactly the same way you would deploy in a local zone, right? The only difference is where that subnet is located. Is that subnet in a regional availability zone? Is that subnet in a local zone? Or is a subnet in an outpost? And so for customers like FanDuel, this means that they can deploy their dev, test, and staging environments in the region and then use the same Terraform templates and API calls to then deploy that environment at the edge. And then from an engineering perspective as well, the fact that things are more consistent means that there's no longer a need to have somebody with expertise in both OpenStack or whatever runs on premises as well as AWS. They can just hire individuals that are well-versed on AWS and use the set of skills to also deploy and meet the latency or data residency requirements. And so, yeah, those are some of the advantages and why customers choose Outposts. With that said, let's go into a hypothetical high-level architecture of what our architectural design looks like for a betting and gaming workload, right? So in the diagram on the left, we can see, again, this pattern of leveraging the region for the non-regulated components, and then a local zone and an outpost for the regulated items. The one consideration that we haven't touched on yet when discussing betting and gaming architecture is really the route that end user traffic takes. So both local zones and outposts support directly ingressing traffic at the edge, as Randy pointed out in his latency use case. But while this is great for low latency use cases, it does mean that now you have multiple points of entry for your traffic that you need to secure. So for my customer and a lot of customers in betting and gaming, they actually opt to centralize ingress. And because the outpost or local zone are connected back to the region, they'll actually opt to send traffic through the region and then proxy it down to an edge location based on a series of checks. And this provides sufficient latency. I believe the latency is still, we're talking about like 30 milliseconds or so. But now they can use services like Shield Advanced as well as CloudFront up in the region and put WAF or web application firewall and those kind of things on the ingress path, and then forward the traffic to the local zones or outposts. And now they only have one point that they need to secure, right? So these are some of the considerations when designing these kind of architectures, and just an example of what my customers do. And then the other question is, well, how about high availability? And we touched on this before. So yeah, like I said, at the moment, we have single local zone sites available in US states where there is a local zone. The only exception here is LA, where we have 2 sites. So as a result, customers may opt to use a combination of a local zone and an outpost, or even 2 local or outpost sites where we don't yet have a local zone or it's not permitted for use. In either cases, again, things like networking become really important, right? So when designing this architecture, when we look at networking, some considerations should include, hey, how am I going to connect my 2 sites, my 2 edge locations together? Should I use an IPsec VPN tunnel over the internet? Or should I implement a direct connect that connects 2 sites together, right? And really the performance that's needed is going to determine what that connectivity looks like. And then the question should be like, if I don't have a local zone in the state or it's not allowed for use, and I'm deploying 2 outposts, how do I connect those 2 outpost sites together, right? Should I put a direct connect in place at both outpost sites and then use something like SiteLink? For those unfamiliar with SiteLink, it's basically a functionality that you enable in your direct connect portal, and it allows 2 direct connects to route traffic to one another. So basically, you can have 2 different data centers that can now communicate each other using the direct connect and that path as the backbone. But yeah, these are all considerations that you need to take into account when designing things for edge deployments where you want high availability, you want to have performance, and those kind of characteristics. And that brings us to the FanDuel use case. This is a bit of a busy slide, but I've highlighted that the portion at the bottom, that's the real important thing. And it's a data point that shows how FanDuel was able to improve their end user experience as well as their internal experience by switching to Outposts for their workloads that are bound by regulations. So, I mean, first and foremost, they were able to reduce their time to market from 15 to 16 weeks to less than 20 days, right? And this was, again, due to the ability to obtain the necessary hardware, as well as the ability to test and set up stage environments in the regions before a state went live, so they can deploy really quickly onto the state. And then again, the next thing is around performance of the workloads, right? So Shiva touched on this a little bit. Outposts really leverage the same equipment as what's found in the region. And so if you're familiar with the regional, our regional networking design, as well as our EC2 design, our compute design, you may have heard about the Nitro system, where we have ASICs that are on the physical hardware that offload things like encryption. We have our own hypervisor called the Nitro hypervisor that minimizes the CPU overhead of running the virtual machines, right? So these concepts all translate into the Outposts, and they're designed in the same way as the stuff that's in our data centers. So again, using combination of that plus a newer generation architecture that the Outposts come with, they're able to see like a 40% improvement in their application performance. And then lastly, of course, there's the operational savings, right? From having to manage less infrastructure on premises. So they also saw some benefits there. Now I'm gonna end off my portion with a lessons learned, and really, if there's anything you take away from this presentation, it's to please loop in your AWS account team. That we can help guide you through the best practices for items that are nuanced for Outposts, such as slotting, which, for those who are not familiar with that term, it's a way to divide capacity on the Outpost so that you can actually deploy instances into it. And then also like networking, how do I design for high availability, right? These are things that your account team can really help with. So please, involve us in the design process and the planning process. And yeah, that's one key point there. The second one is really to plan ahead. Like I said, you're dealing with hardware, especially when it comes to Outposts. So there is some lead time before capacity is made available. So we usually recommend working 6 to 8 weeks out to ensure that capacity is available when needed. And with that said, Brian, I think you wanted to do a trivia. So here's the question that we have.
Wait.
Oh,
So, Yep. Okay. So the way we do it is put your answer in the chat. First one who gets the right answer wins. I'll ask one of the Amazon folks to identify the right answer. And what you win is a Boston AWS mug. Okay.
Awesome.
Yep.
Am I ready to go to the next slide?
Yep.
Awesome. All right. So the question is, what are the 2 use cases that Outposts or local zones can be used for? Pretty easy question.
Was the first answer correct? Okay, do we want to call one of those answers correct?
Yeah, I think the first answer is correct. Yeah, those are the 2 use cases that we talked about in this presentation. Yeah.
Okay. So Utkarsh, if you will send me your postal address, and I'll say that I'm at, and I'll just put it in the my email is, come on, where is it? Okay. If you send me your postal address, I will get a Boston AWS mug sent out to you.
All right, thanks.
Yeah. We're running a little long, but anyone have any other questions?
We are running over, but if anyone wants to show and tell, I actually, while Shiva and Randy were presenting, I de-racked an Outpost server from my home lab. If anyone wants to see what it looks like, what the Nitro key looks like. All right, let's do some. Yeah,
you get nice toys in Canada.
yeah. This one took a little bit to convince to get them sent to me, but let me start my video, and then hopefully you guys can see it. I'm gonna de-blur my background as well. Okay, so the first thing I want to show you guys is this little thing right here.
Oh my gosh.
So when you get an Outpost shipped to you, we talked about Nitro system and the fact that we have different chips on the hardware itself. This little thing right here is called a Nitro security key, right? And so in your Outpost server, you actually plug this in, and all your cryptographic key material is stored on this little thing right here. So whenever we do maintenance or anything on the device where we have to remove the device from the premises, right? We would tell customers to remove the Nitro security key, and you'll see that there's a target right here, and there's a little diagram.
It's upside down.
Upside down. Yeah, a little diagram telling you that, hey, take a wrench or a hex and turn the screw that's behind the sticker. What happens when you do that is it actually destroys the chip that's underneath. And so at that point, all the cryptographic material that was on that server is destroyed, and no one has access to the data on that server. So yeah, so that's a Nitro security key. The second piece of show and tell that I have is how do I plug in the server into the data center, right? So the way that if you're looking at the 1U, 2U servers, the way you connect them to your data centers, we actually give you a QSFP cable. So this end, the 40 gigabit per second end, goes into the Outpost server, and then you have 4 connectors on the other side, and they're actually labeled 1, 2, 3, 4. And so connector 1 is used for that local connectivity back to your data center. Yeah, there it is, connector 1. And connector 2 is what forms, or actually connector 1 is what forms a service link, and connector 2 is what forms a local connectivity back to your data center. So you just plug this into your network. And then lastly, here's the actual server itself. So you can see at the front, there's not really, there's no power buttons. There's no other form of connectivity. You just plug it in, and you'll see this is where the Nitro security key goes. This is where that QSFP connector goes. And this 2U unit, in my case, would slide into your rack, and yeah, you're off to the races there.
So you're holding the cloud in your hands.
I am. And so this thing right here has, I think, 1 terabyte of memory and 32 XL of C6 ID capacity on it. So, yeah.
That's
How loud is it? How loud is it?
Yeah, it's loud. I would not recommend putting it in your 800 square feet apartment. Yeah, the people, your partner or whoever is living with you might not appreciate that. But yeah.
Wow. Thank you so much. This has been fascinating. This is so far, I don't want to speak for anyone else, but this is so far outside my experience space. This was wonderful. And I think in designing solutions, it's definitely something to think about.
Yep. Absolutely.
Well,
Thank you so much, Brian,
yeah.
for having us.
Thanks for the invite.
I do have one quick ask. I'm going to paste a link in the chat. It's just a quick survey that has like 4 questions. If we could take like a couple of minutes to just fill that survey out anytime now, tomorrow, that would be really great.
Yeah, absolutely. So I'll give people just a minute to grab the link. You can fill it out on your own time. But thank you so much. As we said, we're not going to have a meeting next month because lots of us are going to reInvent, and then we have to recover from reInvent and then come up with the recaps and so on. But we will see you all on the flip side. Have a great day. Thanks for everyone coming from different areas. It's funny looking at the demographics. Only about half of our attendees were from the Boston area, which I think is great. And away we go. Thank you all so much. Take care.
Thanks, Brian.
Thanks all.
Bye.
Bye.
Thank you.
Bye, everyone. Thank you.